and or statements, okay?
Mhm.
And what's your question here?
Well, it's just
Give me like a problem, I guess, that we could work through.
okay. There's
Take care.
for an and statement. There's like -5 is less than x, +1 less than 2. I guess that's so simple.
Plus
1 less than 2.
less than 2. Okay, so basically what we have here are two different inequalities, right?
Mhm.
And I'm going to do something real quick. I'm just going to copy this because I'm going to repaste it. And I'm going to draw on this one and make it noticeable what we're going to talk about. So we've got two inequalities. We see that with the inequality symbols less than and less than here. So the first thing that I want to do is get my variable, which is what?
X.
So I want to get x and get it alone, or isolate the variable still. Okay? But I've got two different inequalities, basically. So how, without looking at all the inequalities, how could I isolate just this inequality right here?
Like, take it away from.
Take what away?
Uh,
The positive 1 is what I think you're thinking, right?
Yeah.
So let's take positive 1 away. Well, how do I take positive 1 away, or how do I get x alone?
Subtract.
Yeah, so to undo addition, I'm going to subtract 1 from both sides. But guess what? I've got two inequalities, remember?
Yeah.
So I've got to do what with this 1 still?
Subtract it.
I've got to subtract it from the other side to keep everything balanced. So what I end up with here is -5 minus 1 is -6, right?
Mhm.
Less than x. Well, positive 1 and -1 cancel each other out, and I am left with less than 1. Okay, so now from here, I already know this is an and statement because my inequality x and x is less than, or -6 less than x and x less than, and I'll rewrite that right here. And -6 less than x, and x is less than positive 1, because this is negative here,
Mhm.
and this is positive, so x is in between, right? So let's go ahead and graph these one at a time. I've got an x here, got an x there, and you'll see, oh yeah, that makes sense. So we're going to go ahead and graph all of this stuff. And say, don't want to do that. There we go. Okay. I've got my arrows on this side, got my arrows on this side. I'm just going to put in some numbers here. I got to put 0 down.
Mhm.
And then we'll just do a couple more. I'll say, hey, this is -6. This is -12. This is going to be, I'm just going to call this 1 and this 5, okay?
Okay.
So the first inequality I'm dealing with is, oh, this might not be an and statement, by the way. This might be an or statement. So let's figure out why. So -6 less than x, right?
Mhm.
So I know one thing, -6 right here, right?
Right.
So is it less than or equal to, or just less than?
Just less than.
So my circle, it's going to be open. I'll do that with a different color here. So I have an open circle. And orange doesn't really show up well there. Let's get green, a nice dark color. Okay, so we got an open circle here. And guess what? What way is the x?
It's getting greater.
Then it's greater than, because
Right.
-6 is, so what way does the arrow go?
Right.
It goes right. However, x is also less than 1, so where do I want to circle next?
Around 1.
Around the 1. Open circle. And x is what to 1?
Less than.
So that's going to go in this direction. Hey, do both points connect?
Yes.
Absolutely. I am dealing with all x values in between. And how I crossed out and here, guess what? It is and, because both points are included. What if my arrows went in different directions from each other? It's an or statement. Let's do a couple more and we'll start to understand a little bit better.
Can you ever have an or statement that goes the same way?
So you're saying, can this ever be an or statement?
Yeah.
Well, if both points are connecting, it can't be an or statement. Because this is saying, hey, -6 is less than x, and, or another way to think of this is this. Ready? Let's just talk about the x, the variable.
Okay.
Tell me right here, x is what?
Less than 6.
Well, we have -6, so x is moving in a positive direction. X is
Greater
greater than 6. X is greater than, is it positive or negative than 6?
-6.
X is greater than -6. And here's where our statement comes in. You use and or, dealing with what direction the arrows are going. So x is greater than 6. I'm going to use and here because it's connected.
Okay.
And x is,
Less than 1.
and it's less than 1. So I'm dealing with all points this direction. Okay? Let's look at another one. You got another problem you can show me?
Oh, yes. There's for an or statement, 2x plus, I don't think that's absolute value, but
Restate those values to me again.
2x plus 1 is less than 1.
Okay. Or
x plus 5 is greater than 8.
so let's go ahead and solve these. We're going to work them the same way that we did before. We've got, and this is a 2, by the way, not a z.
Okay.
So let's talk about the variables first. What do you want to do to the variable x?
Isolate it.
Yeah, let's isolate it. And let's just deal with the left equation so far. How do you isolate this left equation?
Well,
What's happening to it? I guess the first question, what's happening to it?
it's being multiplied.
Multiplied by 2 and
Being added.
added by 1. And when I said and there, that's not the same type of statement as an and or statement.
Okay.
I was just talking about what's happening operation-wise here. Okay. So 2x plus 1. So it's saying, hey, x is being multiplied by 2 and added to 1. So let's isolate it. We're going to start with the constants, okay? This constant is 1 here. So I'm going to subtract 1. I'm undoing addition by subtracting 1 from both sides. And now I end up with 2x, not a z, a 2. 2x is less than 1. So walk me through the next step. If multiplication is taking place, how do I undo multiplication?
Divide.
Yeah, just divide by 2. All right. Now since I'm dividing by 2, these guys are going to cancel, and I get x is less than half. Now we go to our next statement, or, and let's work over here. Why didn't I work these equations subtracting 1 over here on this side of the equation?
Because it's a different problem.
Yeah, different operations are taking place, and compared to with the and statement, the same operation was taking place with our variable. Do you understand? X was being added to 1 for both inequalities, whereas down here, there are 2 different operations for x. Okay. Or, so now you tell me to undo addition, you
Subtract.
so let's subtract 5 from both sides. Right? And now you have x is greater than 8 minus 5 is 3. Now let's write that. We'll just rewrite it down here. So x is less than half, or x is greater than 3. And with the or statement, you can already think, hey, the arrows, if I had a number line here, my arrows are going to go, one's going to go off in this direction, one's going to go off in this direction because of the or statement. They're going in different directions. So I guess to answer your question, can you have an or statement where the arrows go, where they head directly into one another? No, it'll never happen. All right, So go with the 0 here. And now, actually, let's offset the 0. You know how I'm putting 0 right here in the middle? Guess what? These are both what? What types of number? Positive or negative?
Positive.
They're all positive. So let's put, I'm not even going to deal with, oh, I might actually. So I'm going to still put it here. Because, and we'll see in a second. Let's do that. Typically, if I'm dealing with positive values, I offset the 0. But I'm not in the case here, and you'll understand why in a second. Let's call this, oh, I don't know. Let's call this 1/2. And then we'll call this 3, and I'll call this 5. I'm just making up numbers, okay?
Right.
Just showing that, hey, some are negative and some are positive. So negative 1/2, negative 3, negative, I don't know, 10. I'm just making up numbers again. They don't have to be the same. So let's look at the variable or inequality on the left here, the x variable on the left, and talk to me about how do I plot the value 1/2 here? What do I do?
Well, it's an open circle.
Open circle. And in fact, I'm going to let you do that. I'm going to give you the tablet, and you're going to take control here. You just have to be real careful. There you go. You'll figure it out. Yeah, so you're going to take 1/2 and keep it an open circle, and the arrow is going to go because x is less than. Yeah, so go ahead and fill that in. Cool, and then make sure that you're doing an arrow that direction.
Oh.
That's cool. Just do Command Z. Cool stuff. So that's one arrow, and then the second circle that we're dealing with is what?
Greater than 3.
Yeah, so where are you going to circle? Yeah, circle over 3, and then your arrow goes the opposite direction. Cool stuff. I'm just going to do some more highlighting here. The first thing you notice right here, between 1/2 and 3, the numbers or the values between 1/2 and 3, there's no connection here. It's the values are disconnected because of the circles not being connected by arrows, right? The or statement saying, hey, these x values, the solutions for x, are disconnected. Okay, that's the first thing. The second thing, I'm just going to re-highlight on top of yours just to make it more colorful. The line doesn't really show well with the yellow, does it? So these are where your values are going. But you did a great job. And grab me another value. Let's do one of those absolute values. How'd you do with those?
That's like the absolute value of x plus 3.
X plus 3. Okay.
Plus 4 equals 4.
Plus 4 equals 4. All right. So this is a little bit trickier. The first thing that you want to do is to, you remember how we isolate variables? We also want to isolate absolute values. So how do you isolate this absolute value?
You want to subtract 4 from both sides.
Absolutely, because 4 is because the absolute value is being added by a number. The way to undo addition is to subtract. We'll subtract 4 on both sides. So now you end up with the absolute value of x plus 3 equals, these dudes cancel out. I'm going to show you in a different color here. These guys will cancel. And 4 minus 4 equals what?
0.
Okay, now this is almost a tricky one, but not too bad. The absolute values tell me something here. The first thing is the absolute value always has to equal a positive value. So absolute, I'm just saying absolute values. If they equal, let's do a different color there too. So if the absolute value
Mhm.
equals a positive number, you'll end up with two cases or two solutions. Um, it just means that you have some extra work to do. It's nothing terrible.
Okay.
And now I'm going to say, hey, but if the absolute value, when I isolate it, equals 0, I only have one solution
Mhm.
for one case. And then the third possibility, what if it's negative? What do you think? If you really follow this chain from positive is 2, 0 is 1, what happens if it's negative?
0, like solution, no solution.
Yeah, there is no solution. So let's go back to this. You already know, hey, my absolute value case-wise only has one solution. And this is what we're going to do. We're going to say this. I'm going to say, I'm going to get rid of, on this next step, I'm going to pull away the absolute value symbols and say x plus 3 equals 0. Okay?
Okay.
And I'm going to isolate for the value of x. What does x have to equal to make this statement true? Or how many spaces away? I'll show you in a second here. So the way to do this is undo addition by subtraction. So x equals
Negative 3.
-3. And that is my value for x. And that makes this value true. Let's make that a different color. And you would just totally wrap that. So, and is that what you have written up in your notes too?
Yes, x equals -3.
Perfect. And did you find that you had any other cases in your notes?
Like one that's like two cases.
Hmm?
One that has two cases.
Yes. Well, oh no, what I meant for here was, did you find that in your notes, this problem had two cases?
Oh, no, it
No, it
just
only had
has
one. Okay. So then the next question here is, okay, what do we have time-wise? Okay, no, we'll ring a little bit. Did you bring lunch?
Oh,
Go ahead and
no,
totally eat. Dig
I'm
in.
fine.
Dig in.
My
Enjoy
braces,
yourself.
I just got braces, so my teeth.
Kind of painful. I hear you. Okay. So you're at -3. What this is really saying is the absolute value of x plus 3 when it equals 0. The value of x is -3 unit, or it's 3 units because, hey, -3, this value here, it's 3 units away from 0. Okay?
Mhm.
So the value of x is -3. All right, let's take a look at one more. Let's look at that one with two cases, and I'll plow through this one.
Okay. I think.
So you read it to me?
Well, for this one, so if it has a positive number, there's two cases in it.
Yeah.
Okay, so I have 4, and then it's like times the absolute value of x plus 2 equals 20.
Okay, so you have a positive value 20 right here. And let's scroll back up. You already said it, but just to go back up, if it's positive, there are two cases. So what you're going to end up doing here, saying this. Well, the first thing you need to do is what?
Subtract 4 on both sides.
Well,
Isolate.
you want to isolate the variable, but what's the operation that's taking place right now?
Oh, multiplication.
Yeah, multiplication. So that's the operation. So to isolate the value of x, you've got to do what?
Divide.
Yeah, so let's divide here. And you're going to divide by 4 on both sides. So you end up with the absolute value of x plus 2 is what? Equals 5. Okay, so now from this point right here, what you get to do is you get to write your two cases. You say this, well, change my colors. Case 1, and then case 2. Right, and now you are up from this point. What you're going to tell me is two things. The first thing you're going to do is get rid of the absolute value symbols.
Right. So we're going to do x plus 2 equals 5.
Yeah?
And x plus 2 is equal to negative.
Yeah. Perfect. So now you want to isolate the value of x.
So you subtract 2 from both sides.
Mm-hmm.
And over here you get x equals 5. And over here subtract 2 from both sides. You get x equals negative.
And you're very close. And what I want you to do is grab a new
7.
grab a new color. We'll just make it a dark one. Okay, now scratch out, do a cross out between the plus and minus 2's. There you go. And do it on the other side too. Now let's look at this one. Scroll your pen over right here. 5 minus 2. That equals 5 minus 2 is 3, right? So let's scratch that out and write down 3. There you go. You're good. And then negative 5, scratch out negative 5 here. Negative 7. Okay. So now these are your values for x. And when you get to this point, you have two solutions of x.
Mm-hmm.
You've got to make sure and check that they actually work. So what you do is you throw it back into the original equation.
So it'd be 3 plus 2 equals 5 or -7.
Now what you actually got to do though is make sure that it's in the absolute value form. Because the absolute value of 3 plus 2, go ahead and what I'm going to do is do this. And then let's just work with, scroll your pen over right here. Let's work with that. What's 3 plus 2?
5.
So the absolute value of 5, write that, equals 5. And what's the absolute value of 5?
5.
Yeah, so write down 5 equals 5. Or the equal sign. 5 equals 5, so is that true?
Yes.
And when you plug 3 in for x, it held true, so you're going to put a check down below on the left. That one works. That's a solution. Now, let's run the second problem. Do a squiggly line right there. There you go, and we'll work this second problem out below. So you're going to plug negative 7 where?
In for x.
In for x.
2 equals 5.
Mm-hmm.
So
If I have negative 7 on my number line up there, right? And I'm going to add 2 to it, what direction am I going?
to the right.
To the right, and I get?
Negative 5.
So negative 5. And it's the absolute value of negative 5 equals 5. You can scroll down the page a little bit if you want. I don't know if this will work. Perfect. So now, what's the absolute value of negative 5?
5.
So does 5 equal 5?
Yes.
You show me on there.
So you do the absolute.
You don't need to do the absolute value anymore.
Okay. So you just do 5 equals 5.
Yeah, so 5 equals 5. That holds true still. So now you check. The one on the right down here. Both solutions are true. So your solutions are, you would write this out. The solutions are x equals 3 and x equals -7. Now just put a big box around that part and you are done.
Thank you.
Oh yeah, absolutely. And did we find that to be true in your notes?
Yes, we said the solutions are both 3 and -7.
Perfect. So what we do from here is press stop, stop.